set 22. I'd like you not to take any notes, just watch, okay? So the first thing we're going to start talking about today is the difference between an expression and an equation. We've been working with expressions. We've been working with 10 times negative 2 plus 6, 2x plus 5, 3 times 2a minus 4, x squared times y times x to the third times y to the second. These are all expressions. I can even do a simpler one. 2 expressions. All right? Now we need to start talking about equations. And they're just, well, here, let me write one. What do you think? Is this an expression? Is this an expression? And what's between them? An equal sign. That's what an equation is. An equation is simply two expressions with an equal sign in the middle. Okay? That's what it boils down to. Equations can be like this. They can be more simple even. That's still an equation. All right? Now this one happens to be a true equation. Are all equations true? No? How about this one? That one true? No, some equations are false. We're not super concerned with that all the time. I think more often we're actually concerned with this. Is this one true or false?
True.
Is that? What's x?
5.
Why is it 5? Why is it 5?
Only x be 1. Because it's just exact.
Okay, could x be a 1? Yeah. Could x be a 0? Yeah. Could x be any number?
Yeah.
Yes. Okay. Now, I understand why you say it's 5. If x is a 5, then is the equation true?
Yes.
Yeah. 5 is the root of the equation. It's the number that makes it true. Okay? But in reality, x can be any number. So this is what we call a conditional equation. It's a conditional equation because it's true or false based on the condition of x. Depends on x, right? If x is a 5, isn't it true? What if x is any other number? Not true. Okay. So true equations, false equations, conditional equations. That's what we're going to start looking at. Now, you've been doing these for a long time. Remember elementary? Right? This is a conditional equation. I believe you wrote something inside the box. Right? What did you put inside the box?
5.
A 5. Why did you put a 5 in there?
Because he equals 12.
To make it true, because 5 is the root. It's the number that makes it true. So you went and you were like, oh, okay, I'm going to put a 5 right there. In this case, empty box is the variable. We don't use empty box for our variable. We use usually letters, something like this. Same exact thing though. We could use empty box if we wanted to. And then we say this. And when we say this, we're just saying, well, this is the number that makes it true. Okay? These two equations are what we call equivalent because they have the same solution. The same one makes them true. Do you guys realize that's an equation? Do we have an expression on the left? Expression on the right? What's in between? It's an equation. You always look at it like it's an answer, don't you? Okay, but it's an equation. It says, what number x equals 5? Well, obviously it's 5, right? This one says, what number x plus 5 equals 12? When you read it, you probably say x plus 7 equals 12, right? That's not how you read this. You read it, what number plus 7 equals 12? Every single conditional equation is a question. Right, Jack? So when Jack sees something like this, he's going to think 2 times what number plus 6 equals 12? It's a question. That makes sense? It's always a question. Always a question. Now, you're not going to have to solve equations like this. And you're not even going to have to solve equations like this yet. I'm not going to give you an equation and say, what's the number that makes it true? What is the root? That word root. What is the root of the equation? I'm going to make it easy for you. Yes?
I know the answer to that one.
Oh, good. Yeah, we'll talk more about that. We'll get there. Okay, so we're going to be given some problems that look like this. What do you think that means? Do they satisfy the equation? Yeah, do they make it true? Are they roots of the equation? Are they solutions of the equation? That's all the same thing, okay? So how can we find out? Now there's two separate questions here. Does -2 satisfy the equation? Does 5 satisfy the equation? So there's two questions. You have to do them both. How are we going to do it? Can you think of anything we might have learned this year? Yeah?
Replacing the x with one of them.
Yeah. Now, we've learned how to do this already, haven't we? Replace the variables with parentheses, put the -2 in, and parentheses matter, don't they? This is +4. Without the parentheses, what would it be? Yeah, it'd be -4. Yeah. Equals, isn't that +10? Subtract 6. Okay, so what do you think? Does -2 satisfy the equation?
Yes.
Yeah, it's a root of the equation. It makes it true. It's a solution. Okay, now, don't think because one works, the other one won't. That's not the way it is. It's possible that both will work. So if we plug in the 5, does 25 equal -25 subtract 6?
No.
Okay, so that one doesn't work. Okay. Now I will tell you though, usually when you have x squared in the equation, there are 2 values that will work. There might only be one, there might be none, there might be infinitely many, anything might work, but generally there are 2 different numbers that will work, okay? If we have x to the first power, then generally there is just one value that will make it true, okay? One root. There might be nothing, and there might be infinitely many somethings, but generally one. And the nothing and the infinitely many, they're both kind of bad deals. They usually mean that you set up the equation wrong. Let me give you an example. Here. Can you think of a number that might work in this equation to make it true?
7.
Yeah. Can you think of a number that won't work?
No.
No, they all work. It doesn't matter what number x is. Now remember, in this problem, you can't have a different value for x in the two different places. Whatever it is, it's the same thing. Okay? It has infinitely many solutions. Is that very helpful? Anything works? Nah, usually that's not a deal. And then you could also have something like this. Tell me a number that will work. Yeah, there's nothing. There is no number you can subtract 3 from and then add 5 to it and get the same result. It just can't happen. So there is always the possibility of infinitely many solutions or no solutions. Either of these situations means you probably set the equation up incorrectly when you did the problem from a real life situation. It's usually not a good thing. That's not what we usually want to do. If you get x squared in there, generally how many solutions will there be? Does that seem weird that two different numbers will work? Because usually you look at something like, let me make an easy one. Can you guys see the root here? You can just look at it and tell me the root, can't you? What is it? 4. Yeah, it's 4. That's the number that makes it true. Can you think of any other possibility? Yeah, that's it. That's the only one. And so, you know, when we have x to the first power, usually that's the case. There's one number that makes it true, and that's it. But it is possible to have more than one. So let me give you this problem. Okay, so your side of the room, you guys all try the -2. This side of the room, you all try the 5. What are you seeing? Did they both work? Yeah. They're both solutions. They both work, which is kind of weird, but that's the way quadratic equations usually work. Two different things will work. Okay? So, there you go. Let's take a look at set 22. Let's take a look at the first couple questions there together. What is an equation? A problem? A question? I want you guys to say it's two expressions with an equal sign between them. Two expressions with an equal sign between them. That's what an equation is. Some expression, 2x plus 7. Some other expression, 5y plus 2, equal sign between. That's what makes an equation. Don't write an example for me. Write out the words. Two expressions with an equal sign between them. It can even be super simple. Here's an expression. Here's another expression. There you go. And then part B, what is a conditional equation? A conditional equation is simply an equation with a variable. If you have a variable, then a conditional equation is a question. So If you say it's an equation with a variable in it, that's fine. So remember, we had true equations, we have false equations, and we have conditional equations. That makes sense to everybody? So if we had a quiz Monday and I said, write down a true equation, could you do it? Write down a false equation, could you do it? Write down a conditional equation, could you do it? I didn't get a definite yes on that one. Okay. Okay, and then number 2. What do we call the replacement values of the variable that turn an equation into a true equation? I use the word. It has something to do with a tree or a plant. Yeah. The roots. The roots of the equation are the numbers that turn it into a true equation. Okay, keep going. You got time to get it done in class. My last period class, they got this done easy. No homework this weekend. Let's go.